Hey guys, so welcome back. We're working on this 1953 Chevrolet tube type AM radio. It's for a 1953 Chevy 210, and each one of the videos in this series are all covering a different topic, so they're kind of separate. At the end of the last video we did, we were listening to the vibrator going on in this radio's power supply. It was just buzzing right along, and I mentioned that in this next video we'd be addressing that next. So let's take a look at doing a retrofit of a solid state vibrator to put in this radio. So that's going to be the subject of this video. Let's get started into this one, part 4. So I mentioned a while ago that we have the vibrator in here. You can still hear it buzzing maybe. So the owner of this was interested in getting a solid state vibrator installed. So I bought one, got it already built, and so here it is. I'll put a link to it below so you can see which one this is. It's from Radio Joe, I believe it is. wjoe.radio LLC, I think is what it says. wjoe.com. Anyway, so I bought this already assembled. This is for a 6-volt negative ground system. And the idea is, well, maybe we'll mount this in here and we'll see how it does. So I've already decided I don't want to wire it in permanently. I'm going to use the base of a old vacuum tube I have. I'm going to take the tube out of it and just use the pin base and try to attach this in there and use the pins and plug it in like the vibrator on the other side. So it's got a ground and it's got the leads that go to the transformer here. Okay, and then we'll see how that performs. It's going to take a little bit of work to get that mounted to where I can get that in there. The other thing I might do is, before I go to all that trouble, is I think I'll take this cover back off, I'll take the vibrator out, and then with leads I'll hook this up to the bottom side of the tube socket, and then we'll see how this performs before we go to the trouble of mounting it. Make sure we like the way it does. So let me get started on that, and I'll get this clipped into there after I get the old vibrator out. Okay, I've pulled out the vibrator. This thing is still hot. I've hooked up the 2 leads that go on either side of the transistor, and the other lead goes to ground. So I've got them hooked up down here. I've got the solid state vibrator here. One of the hot leads is here. The other one I've got tucked into this bag so they don't get into trouble. And the ground lead I have underneath the plastic handle of the screwdriver over here to hold them all separate. So we'll bring this thing up and we'll see how it does. So reset my meter so they don't wig out on me and halfway through the test. Okay, DC volts, amps. I've got the dim bulb back into the circuit, and we'll see how that does. Bring voltage up slow. Dim bulb is in the circuit. It's going to be weird not hearing the vibrator running. Connecting the antenna. Okay.
All things going with Justin Britt. I mean, Questenberry did a good enough job last week. Got gold for the 1 hold, but in theory, they haven't missed a whole lot from him. Where is his status right now?
Okay, that's the tops with the dim bulb in. You see it glowing through here. Okay, I'm going to turn this down, take the dim bulb out. Okay, dim bulb is out of the circuit.
I'll let you run. How battered and bruised are the Chargers going into this week's game? Because, look, the Jaguars went out to LA this past weekend and beat them up pretty good.
Yeah, the Jaguars are great where Justin Herbert is really dealing with the injuries staying there.
Things are to get dramatically improved.
Okay, so the solid state vibrator seems to be working just fine. I'm going to look at now mounting it in that socket with an old pin tube base, and I think I've got one I can use. Okay, so this is probably my least performing number 80 I have. That's on one diode. That's the other diode. So I could still use this for testing, but I have some others that perform a little bit better than this, so I think I'll sacrifice this one here to the project. I mean, it might work. I think it did work, but not one I would put into a project. I put a lot of work into fixing. This would be good for testing, but I've got another one that performs a bit better than this for that purpose, so I'll use it instead. Yeah, I really hate to do this, but it doesn't function that well, and well, here we go. You can do this without getting hurt. Okay. Okay, it's been several days later. I had a lot of other things I had to go do, but basically I allowed time for this to set up. So basically what we did is we took that tube and we took the glass out of it, and then I mounted the solid state vibrator in here, and then I've potted it in with RTV, and yeah, it's the right kind. This is the kind that's non-corrosive to electronics. It's not, doesn't have acetic acid in it. So anyway, it doesn't give off acetic acid, whatever the chemistry is. So basically this is safe for electronics. So it's got a couple of FETs in here that are used to create a square wave, and that's about all there is to say, except let me tell you how I had to pot this, because it took a little bit of time to figure out the easiest way to do it. So the easiest way to do it is that, of course I used my desoldering station and sucked the solder out of these tubes and cleaned them up real good. I ran a small drill bit through them to make sure I didn't have anything hanging up on them in terms of like a whisker or a drip of solder and so forth. So then what I ended up doing is I desoldered these 3 power leads that are here. Okay, so I unsoldered these 3 leads here. Come on, focus. Here. And then cut them to the right length and strip them, and then pass them through down here and soldered them into place. Okay, so that their length was just about right. Okay, insulation goes right down to the very top of the pin socket, if you will. Okay, then I positioned the board in there, and then I resoldered those 3 connections. Okay, and then check continuity, and then I put a bunch of this RTV, special electronics grade RTV in here to hold that all in place, and that's just really super solid. Okay, it's not going anywhere. Okay, and this is really set up quite well. All right, so the next thing to do is put this in the radio, and then we'll see how it performs. Okay, so I've got the solid state vibrator in place here. It's on the other side, of course, and I think I've got everything rigged back up right. I had to take things down and have to rehook it up again. So this is the schematic that was out of the shop manual that I mentioned had the correct values, or at least for this chassis or this particular production run, of the resistors that are in here. So I'm going to use these voltages as the go-by. All right. So this is looking for 6 volts where the voltage comes in, which is where I'm measuring it, meaning right here where it first comes in here. And then I'm going to be measuring the first place I really have a good voltage out of where the vibrator is going to be coming to the plates of the rectifier. So that'll be AC. So I'm going to be measuring for 275 volts AC. And the way I'm doing that is I'm just going to pick it up off of one of these legs of this capacitor right here, which is located here. Okay, I think it's time to bring this on up. We'll see how we do. Okay, so I'm set up to go run this now. We've got 120 volts coming in to the power supply. Do not have the dim bulb on the main side, but I have the dim bulb back here for the 6 volts going through. We'll be measuring DC voltage out of this at this point here, and we'll see what we get. Okay, so here we go. Voltage down, voltage coming up. Power switch is on. We're getting amps. We're at almost 2 volts DC. 4 volts. At 240 volts AC.
Lines one up the middle for line drive. Yeah, but we want to see good contact from Altuve today. We want to see some other guys step up. We love Jordan playing the Euro the other night. Oh, we want to see some other guys in this lineup.
So we're back down to 171 once we had conduction, I guess. Bring it on up. That was a heck of a hit by Alvarez, huh? Okay, I'm up to 4.7 volts. DC going in, we're at 4 amps. We're at 225 coming out of the transformer. As you can see, the dim bulb's glowing pretty good back here. So I'm going to say that we don't have a short. So what I'm going to do is turn down the input voltage, and bypass the bulb and bring the voltage up higher. Okay, we're at 6.1 volts, 5.5 amps, 284 volts. That all looks good. So what we're doing, once again, is we're measuring the voltage here at one of these plates for the rectifier. Okay, so what I'm going to do is switch over to DC and go to the cathode of the rectifier. And that'll be right here. Alright, and that should be 250 volts. Plus 10% is another 25, so 275 is kind of the high end there. We're at 6.1 volts over here. So I need to trim that down a little bit. Okay, 6.1 still. 6 volts. Okay. It's supposed to be 250 plus minus 10% be 275. And we're right at 275. So we're doing really good there. Alright, so it seems to be working okay. Let's
To host the Mariners in Game 2 of the AL Division Series.
Okay, that all sounds really good. I'll check a few voltages and we'll see how it looks. I'll let you know if I see anything weird. Okay, so I've gone through here. What I've found is that the plates all seem to be okay, except this one. This one's supposed to read 97. I've got like 160 volts on this. The rest of these are all at plus 10%. This screen grid is high. It's reading 230 volts. So that's 15% high. Okay, so this time I'm going to follow directions. The instructions is that you're supposed to do it with no signal. Right. So what I've done is I've pulled the antenna, and then when I hooked up some connections, even the connections started getting receiving. So I retuned it so that I was off of station. Now let's see what we get. We're at 6 volts. This is supposed to be 5.5 amps. We're within range there. Okay, we're set up in AC volts. We'll go to check here on either side of that capacitor, which should be 275 plus or minus 10%. So we'll go AC. Come on. There we go, 275. Okay, now what we're going to do is go over to other side of the rectifier, 250 on the cathode. We'll pick it up on this side of the intermodal, which is here. Go to DC. Still at 6 volts. 262 for the 250. So within 10% there for sure. Okay, what we're going to do is go on the other side of that resistor, which will take us up here to the screen grid here, which is supposed to be 205 plus or minus 10%. So we'll pick that up here. Much better. 212. That's nominally 205 plus or minus 10%. We're good there. Okay. What we're going to do is all right, we'll check this. The plate of the audio output tube is going to be on the other side of the coupling capacitor. That's the coupling capacitor. I'll pick it up here. It's supposed to be 110 volts. We're at 103. That's fine. Okay. Let's see. The plate of the IF is pin 5. Should be 200 volts. Pin 5. I think that's here. No, that's not it. Pin 5. Oh, yeah, it's here. Okay, 189. That's supposed to be 200, so we're fine there. See, it's building up. It's good. Okay, we'll go to the other one, which is 1, 2, 3, 4, 5 of the oscillator, which is back here. 5 of the oscillator. Is this here? And that's supposed to be 200. We're at 213. We're within 10%. Okay, now the plate of the RF amp should be 97. You'll see I've changed that resistor. I've also changed the tube. I may change it back. You see I'm starting to get a little bit of a signal there. But it's supposed to be, what does that say? 97 volts. Now we're at 113. We're within range. Okay. That's looking much better. So I did change the tube out just in case I was getting something funny there. But I may put this one back in because this one measured better on the emissions. But anyway, the other thing I was going to check is this one here. Okay. This one's reading low to me. It should be 6 volts on the cathode. 6.5 volts on the cathode of this, and I'm getting 0.6. Now I've checked that resistor that's there. It's a 68 ohm resistor. It measures 68 ohms. So what's going on with this cathode? I don't know. I may change that resistor out. Maybe I don't have a good connection on the pins. Let me wobble that a little bit. No, that seems like it's okay. Okay, I've had this playing for quite a long time, and I've been thinking about this issue with the voltage that we're measuring up here. We were expecting to get, according to this, it says 6.5 volts there on the cathode of the RF amplifier, and I was getting much less than that. Remember, you got to do this with no signal, so I'm going to pull the antenna out here and watch. Okay, about 0.6 volts. Okay, so I got to looking into this and trying to figure out what is going on. How could I be off by that much? So what I did is that I got into one of the RCA manuals and did some homework. I went to the 6BA6, remote cutoff pentode. Okay, and I got to looking at this, and I was thinking, okay, look, the voltage I'm going to get on that cathode is going to be based upon the current that I have going through that resistor, right? Because I'm measuring the voltage between the ground and that point, okay? And this is going to be DC, right? Pretty much. And you know, it's vehicles IR, right? So I know the resistance is about 68 volts. I mean 68 ohms. I measured it. So I ought to be able to say, well, what's the current of the cathode? Cathode current through the cathode bias resistor. And so what should it be? Well, the manual doesn't directly say, but think about it. The current of the cathode needs to be the same as the plate current, plus maybe, you know, maybe the suppressor grid or something like that. So anyway, if you look at this, these are maximums, okay? These are maximums. If we have a plate voltage of 100 volts, okay, and we know that we're getting plate voltage should be around 100 volts, 397, so let's call it 100 volts. Our maximum plate current is 10.8 milliamps. And if I want to add in the, the suppressor, or the screen, sorry, is another 4 milliamps. I mean, we're into the range of, small amounts. But remember, these are maxes, okay? So let's just say for grins that we're going to get 10 milliamps of cathode current, right? Because it has to, these two are going to add to that. Let's just call it on the order of 10 milliamps, all right? Well, if it's V equals IR, right, you can say, all right, I mean, I don't really need a calculator for that, but I'll show it just so it's easier to illustrate. So we know that the resistance is 68 ohms. And we know that the current is on the order of 10 milliamps. That's 0.68 volts. I was getting 0.6 volts. So we're in the right range in terms of, orders of magnitude, right? So I'm thinking, is there any other source of where I can look at to get some kind of check on this? Well, this was the schematic I've been using, right? Because it had the right values down here for what I was actually getting on these automatic volume control resistors for the AVC circuit. And it was giving me 6.5 volts. Well, what if I look at the other schematics I had? Here's the one that I was using much earlier. If I look on this one, it says it should be 0.45 volts. Okay. And this other one I have, all right, this is 0. So I'm thinking, did somebody miss a decimal point? Is this wrong? And that should be 0.65. I think so. Anyway, everything else about this is looking good. So I think what I'm going to do is button this back up, put the cover back onto here, and I may go in here and change this coupling capacitor just so I'm happy that that's a good, fresh new one. Everything else I think is going to be fine, and I'm going to button that back up, and the next order of business will be to do the alignment. Okay, so I changed out the grid coupling capacitor, and I'm measuring it. As you can see now, as it samples, you're getting some negatives as well. We weren't getting the negatives before, so yeah, I changed this one out. It was probably fine, but I like being careful of that cap, so we've changed it out, and I think we'll be a lot happier with this one. So anyway, let's say it flashes negative from time to time as it samples, so it's blocking all the DC. Good news. Yeah, so I put the other RF tube back in that had better conduction, all right, and here we are at just under 6 volts. I can get that up to 6 volts. If you look over here, the cathode current is up to 0.63. So definitely conducting better, getting better current through the cathode. This thing's working just fine. I'm going to put the cover back on here, start looking at doing the alignment. Okay, getting set up to do the alignment here on the radio. I've got my signal generator set up over here. When I turn it on, we'll be able to see the frequency over here in my frequency counter. I'll turn that on so you can see it starting to light up. Got it back there in the shadows so we can see it in the lights. So I'll be tuning that to the IF frequency. When I turn it on and let it warm up for quite a period of time before I go in and make adjustments. So I'll get this all set up and get the current going, but I'm just going to explain what I'm going to do on the procedure. Okay, so on this we're going to do some adjustments. Maybe don't need to do any adjustments at all. Maybe just checking to make sure that everything looks okay. So basically you're just checking to make sure that the these coils are getting the right inductance out for these capacitors and that they're peaking at 262 kilohertz, which is what you have for car radios instead of 455, which you typically have for house radios. Anyway, so I'll be doing that core, that core, that core, that core, and then later on we'll be getting into trimming these capacitors here in the oscillator and the antenna section. And then the last thing we'll be doing is checking the trim on the antenna itself here. We'll be just kind of getting it in the ballpark. This would have to be matched to the actual antenna mounted to the actual car eventually, and I'll show where that can be done later on. The other adjustments like K, J, and so forth, these are H. These are for adjusting the actual permeability cores that are in here. I'm not going to touch those. They haven't been touched, and I'm sure they're fine. So I'm just going to leave those be. But when I change these other items out and so forth, it could possibly affect the alignment of the IF system. So we'll just be checking that and just make sure it's okay. I'm not going to get probably too in depth with it, but in other words, it should be okay to start with. But we'll just check it. All right, so the IF transformers, let me get some of this out of the way. We'll look around what we got here. Okay, so we've been looking at the bottom side of this for most of the time. On the other side of the radio, which as it sits in the car would be down, right? We've got, zoom you in. Okay, here you can see the solid state vibrator installed. All right, here's the rectifier. Here's what, this is the old capacitor. It's electrically removed. I just left it standing here though for looks. This is the audio output transformer. This is the new audio output tube. And then we've got the tube array that goes in the radio, starting with the RF tube, the oscillator converter tube, the IF amplifier tube, and then the detector AVC first audio tube are here. This is a sensitivity control. It adjusts the cathode resistance on the IF tube. I can't find any instructions on how to adjust this. A lot of things that'll say voltages and so forth will say subject to what this is set to, but I don't see anything that says how to set it. It's called a sensitivity control. I'm probably not going to mess with it. It's a 150 ohm wire wound, I believe, and it's around 138 is what I've measured, so I'm just going to leave it be. And then the other adjustments I was talking about is I believe this will be the oscillator for speeding up or slowing down the oscillator. This is the antenna for the tuning system, and then the antenna itself, which is connected here, is adjusted by here. And just so people can see, if you're looking at the bottom of the radio when it's installed, normally there is supposed to be a sticker or a label on the bottom of the radio so that a service person can, when they install the radio, trim the antenna from the car to this unit. And so when they look into here, okay, that item will be accessible here. These other ones do not need to be touched. They should all be set fine. They don't need adjustment. But when the antenna is matched to the car, it might make sense to go in there, put a screwdriver in that hole. I'll label it. It's called G in the manual, and that will allow that to be tweaked. And that's just so you can get the best reception on a weak station. This will be when I'm adjusting the IF cans. These are the IF cans. And this is the last one. This is the first one. So this one will have cores 1 on the bottom, 2 on the top. The first one will have 3 on the bottom and 4 on the top. Or as it says in this manual, this one here has A on the bottom, B on the top, and then this one has C on the bottom and D on the top. And I'll work my way back. Okay, so I've had the radio playing for about 3.5 hours. And so everything's warmed up and it's all settled in and everything. So I'm going to go back and go over a little bit with the alignment with you. I've done a quick touch-up of it to just see if I was in range and so forth. And I'll just show you a little bit of the peaking. But we're right in there. So what I did is following the instructions from the different manuals I've got it set for the IF frequency, which is 262 kilohertz. Not 262.5, but 262. And let's tune that in. You see why I have this frequency counter. You don't have that kind of resolution on this kind of dial. Does it need to be this accurate? No. Then what I did is instead of using a 0.1 microfarad capacitor to hook up the output of the generator directly to the grid of the oscillator, which would have been right here, what I've done is I've instead just clipped the lead on this wire. Okay, so it's inductively coupling through the insulation, if you will. There's an air gap there, or insulation gap, and so I'm clipped onto that lead. So I'm clipped on right here, and I'll zoom in so you can see it. Yeah, so I'm just clipped on to this insulation right here. The connection would be right back in here. Anyway, so I've got this on. Let's go back out a little bit. Okay. That's about as close to 262 as I think I need to be. Okay, that might be a little better. All right. I'm going to turn on the modulation. The volume is to be all the way up. I've disconnected the input. I tuned it off of a station first, and I had the volume turned up all the way. And so now I'm going to turn on the modulation. The frequency counter is not going to be accurate anymore. And then bring up the modulation until maybe we can hear it. I can barely hear it there. So what I'm going to do is I'm going to switch scale on the, it says attenuator, but it really ought to be level. So go high. I believe you can hear that. So the objective here is we have this turned up all the way so that we're hearing what's going through the IF stages as much as possible. We want to be able to just hear it. But the level is so low that hopefully the automatic volume control is not doing much to us to suppress the signal. Okay, so I'm pretty close to peak now. I've got an insulated screwdriver. I'm going to turn it up just a little bit so maybe you can hear it. And I'm just going to go through. I'm going to go to A, which is on this side, B, which is on the other side of those IF cans, and then I'll go to C and D. C will be on this side, D will be on the other. And you see you can hear the volume level go up and down. I want to just peak it to where it's, it's loud. Okay. So this is A. So I think it's loudest about there. So now I'll go around to B. Okay. Lower. Higher. Higher still. Okay, I'm going to turn this down a little bit. So remember how loud it was before I turned it down. Okay. It feels like it's about the peak there. We go back to A again. Okay, it seems to be about peak there. Now we'll go to C. It's up here. I'm working my way back from the second IF down to the first IF, working myself closer to the oscillator. Okay, just a quick check, go back to A, B, and C. Okay, so what that should do is really allow the filters to be fine-tuned and sharpened up right on the IF frequency. And we'll just see if we got them aligned okay and how it sounds. I'll turn the volume down. Okay, remember I was off of a station. So let me turn to a station.
So don't wait, folks. The midterm.
Mouth-watering assortments of perfectly aged steaks.
National broadcaster.
Picking up stations up here on the high end I didn't hear before. Let me go up to the top. I wasn't hearing that station before. That's a strong station. I was hearing it. There's a DX station in there. Another one. Didn't hear that station before. Another one. So there is selectivity. Two really weak stations, and I can tune both of them. But the sensitivity is pretty good. I mean, I'm actually able to understand that. No idea where that station is. Another station in there. Probably pick these up better if I wasn't in my shop with all this gear in here, making noise.
So important as well. The experience that we've had has kept us coming back now for more than 15 years.
Okay, that's San Antonio.
Online right now and find that perfect
That's
vehicle
WAOI at 1200.
You can actually find the exact vehicle you want before you even go to the dealership.
See how many miles away that is, roughly.
Make sure you
So that's roughly 185 miles away.
only pay for what you need at libertymutual.com. Finding great candidates to hire.
So that's pretty good. So we're getting a lot of stations. So let's go to the next stage of the alignment. Okay, so now what we're going to do is we're going to adjust the oscillator, the antenna front end, or the antenna here, the RF I guess we should say, the RF coil, and then we're going to do the antenna here. So we're going to do E, F, and G. We do that by connecting up the signal generator. Instead of here, we're going to connect it up basically to here. Okay, let me get that set up, and then we're going to set it at 1615 kilocycles. Okay, let's do that real quick. Now it says 1615 in the SAMs. And it says to turn the dial to the high end. So it's all the way at the top. Now, so the SAM says 1600, the shop manual says 1600. Sorry, SAM's manual says 1610, or rather 1615, and the shop manual says 1600. I'm going to try 1615 and see how that works. Okay, I've got the signal generator set up for 1610, and I'll turn on the modulation in just a minute. I've got the connection to it. Yeah, so this is Mr. Future back with you. So when I edited this video, I realized that I had said it needed to be set when I was doing the oscillator adjustment, that it needed to be set at 1615. And I did that, but then when I got around to actually doing it, this had drifted back to 1610. So I'm not going to think it's going to make a whole lot of difference, but just you'll see, I'm going to go ahead and fix that. I also filmed this where you can maybe see what I was adjusting a little bit better. You see that okay? I'm at 1615. Okay. So here's the tube side of the layout. You can see I've got the shields back in. The strainer leaves, what do you want to call those, the supports. So what I'm going to do is, these are the controls that I was adjusting. This is the oscillator control. This is the RF coil, I shouldn't say control, adjustment, the trimmer. And then this is the antenna trimmer. Okay, so I'm going to adjust this for the oscillator, then I'm going to change to 1000 hertz, and then we'll adjust the RF coil and then the antenna trimmer for that. Okay, we'll go through that process. Let me flip on the modulation. So as you can see, we're at 1615. Okay, modulation on. Turn it down a little bit. We're going to let it stabilize for a bit. So now what I'm going to do is turn that adjustment just for maximum output. Okay, that's where I'm getting a good waveform at maximum scale, right about there. You can kind of see what I'm talking about if I swivel you around just a little bit. So then what I do is go back, adjust the frequency generator, turn off modulation, go to 10,000 hertz, or sorry, 1000 hertz. And now I adjust this for right at 10,000. That's going to be impossible. There's no markings for it. I'll put it in the general area. I'll just say that's close enough. Turn on the modulation. And now what we want to do is tune. Let's see. Tune this down right in there. And now we'll adjust those last two adjustments again. So it's about there. Okay. Readjust the antenna. There we go. Got it done right. Alright, let's see if it looks like it's on 1200. Spot on.
Just can't find overfry. Maybe it's my ears. Gotta clean my ears every
No, it's substantive due process precedents, including Griswold.
Done nothing.
For how, what, and where they drive their team of experts at.
Everything I've looked at is at least 20% lower than what we have been looking at it.
Alright, alignment's done. I think it sounds pretty good. I'm going to put the bottom and the top back on it, do another quick run through, and then we'll see if that's finished. And you can see there's plenty of room, space between the top of the solid state vibrator and the case. Looks like at least a ½ inch or thereabouts from the top of the heat sinks to this. That's great. Plenty of air circulation around there, as you can see. Okay. There we have it.
The Chris Salcedo Show, where conservatives find their voice. AM 700 KSED.
Okay, I'm maxed out at about 5 volts
The voice of Texas.
because I'm running through the dim bulb.
News this hour from townhall.com. I'm Tasha Stevens.
Refunds.com. Get refunds on Sports Talk 790 Houston. My friends in Miami.
The majority of Americans do not want abortion.
Good work on the East Loop southbound at Port of Houston, the outside lane.
1-2 Philadelphia, winning at San Diego 2-0. Bryce Harper a solo homer in the 4th. Kyle Schwarber a long solo shot in the 6th. The Padres offense had a...
Looking good. I got to talking with the owner about the issue with the transformer. If you remember, the transformer looked like a lot of tar had leaked out of it, but the other side of it was that there was a capacitor inside the transformer. I'll pop it up here on the screen. So when this was recapped, I don't know if that capacitor that's in there was replaced. I'm going to actually assume it probably was not. So, you know, partly because the tar leaked everywhere and it doesn't look like it had been cleaned up or that the transformer had been removed. So this is a classic, you know, risk-reward deal of, do we go in there and see if we can get that transformer off to see if that old capacitor is in there so that we can take that out. Now, operation-wise, the radio seems to operate fine, but you know, if we can get the transformer off, it'd be nice to see if that capacitor is there. Maybe we can change it. So what we've agreed to do is that I'm going to open this thing back up and go after that transformer and see if we can get that out. I'm going to go in there and kind of pick at that tar and see if I can get it loose. But if I think that it's going to get to where I'm going to possibly damage this radio, I'm going to stop.